You're sitting in a lecture hall at Rutgers University, notebook open as Kenneth Rosen flips the page, diving into how a tiny group of numbers can unlock the secrets of computer code and logic puzzles. Why does discrete math matter anyway? What makes it the invisible backbone of everything from social networks to DNA sequencing? Hang tight, because this book doesn't just teach formulas, it rewires how you see patterns hidden in chaos. Think you know logic? Rosen flips it on its head here. We go beyond simple true-false truths to see how complex truths are built, cracked, and applied every day. In the 1960s, Peter Wasson gave a simple card puzzle. 4 cards, each with a number or letter, asked which cards must you flip to test a rule. At first glance, it feels trivial, but it reveals how people struggle with conditional logic in everyday decisions. Rosen uses this to show logic's human flaws and power. Imagine logic gates as traffic lights in your brain's city. And means both lights are green, or means one green is enough, not flips the color. This circuitry explains how computers crunch data at ridiculous speeds, all based on simple true-false switches, flipping billions of times a second. Here's the kicker. The same logic principles that program robots and parse languages are what judges use for legal reasoning or marketers use to predict behavior. Discrete math is the quiet engine behind countless decisions that shape our world, often without us even noticing. Counting isn't as simple as 1, 2, 3. Rosen unlocks the explosive world where counting rules reveal everything from genetics to cryptography, where just one twist can explode possibilities. Picture a full poker hand, 5 cards from 52. Rosen walks through how to calculate just how rare a royal flush really is, breaking down combinations and permutations with sharp precision. It's not just math, it's the DNA of chance and risk, crucial for gaming and logic. Ever shuffle a deck and wonder how unique it is? When you permute or rearrange objects, you generate staggering numbers like 52. That's 52 factorial, a number so huge it dwarfs stars in the universe. Discrete math gives you the tools to grapple with these mind-boggling scales. Counting rules don't just apply to cards. They're essential in coding DNA sequences, encrypting messages, and spreading data safely over networks. Every cell, every secret message uses discrete math's counting magic to survive and thrive. From Facebook friends to city streets, graphs map connections you can't see. Rosen reveals how these networks model everything from social chaos to viral outbreaks, transforming data into clarity. Remember when Facebook friend suggestions seemed almost psychic? It's graphs doing the heavy lifting, mapping nodes, people, and edges, friendships. Rosen dives into these models, showing how just a few connections ripple out to create viral trends and communities. Leonhard Euler's 1736 solution to the Königsberg Bridge problem wasn't just a math curiosity. It laid the foundation for graph theory. His trail-finding approach models how delivery drivers optimize routes or how internet data flows efficiently across millions of points. Graphs aren't limited to tech. Rosen shows how biologists map neural networks in brains using graphs and how search engines like Google rank pages by analyzing link structures. This magic in the mesh turns complexity into insight, letting us predict, optimize, and understand connected systems. So back to that Rutgers lecture hall, Rosen's equations aren't dusty abstractions. They're keys to unlocking the digital, social, and biological puzzles around you. Next time you think of a friend's social feed, a shuffled deck, or a legal argument, remember, discrete math's quietly working behind the scenes. Try this, spot a simple logic puzzle or network graph in your day, and see the patterns unfold. Subscribe for more book summaries like this one.